Welcome back, everyone. Today we're going to be talking about RE3, which is fractions and exponents. Your objective today is that you will be able to expand and simplify a fraction that is being raised to a power. Before we get into it too deep here, let's just go over some basic understandings of fractions, because in my experience, kids don't like them much. When you are looking at fractions here, and they're being multiplied. Multiplying fractions is one of the easiest things to do with fractions. And fortunately, when you deal with exponents, that's basically all we're doing is multiplying fractions together. So the way we're going to multiply fractions is we're just going to go straight across every time. We're going to take 4 times 4 and 3 times 3, and that's going to give us our new fraction. So 4 times 4 is, of course, 16, and 3 times 3 is, of course, 9. Now, that's all fine and dandy and good, but what happens when we get to something that's being raised to a power? Now, when you have a fraction that's being raised to a power, or really any base that's being raised to a power, all we do is we take that base and we multiply it by itself 5 times. So we can rewrite this and simplify it to say that this is the same as 4 fifths times 4 fifths times 4 fifths times 4 fifths times 4 fifths, right? Because that's what it means. Take the base, multiply the base by itself 5 times. And that's what we've done now. 4 fifths times 4 fifths times 4 fifths times 4 fifths times 4 fifths. Now, what we're going to do is we're just going to multiply straight across. All of those 4s are going to get multiplied together. Now, let's think about this. Since it's 4 times 4 times 4 times 4, maybe times 4, I can't remember how many times I've said it now, but we're multiplying 4 by itself 5 times. We can actually say that as 4 to the 5th power. Now on the bottom here, if I have 5 times itself 5 times, we could also say that as 5 to the 5th power. Now I want you to notice something. It looks like that 5, that exponent of 5, we took the top, the numerator here, and we raised it to the 5th power, and we took the denominator and raised it to the 5th. It looks like that 5 goes to both of them from what we can see right here. So let's dig into that a little bit more. That's where we get our new exponent rule for the day, the product of a quotient rule. And just like we did yesterday, I want to tackle this from just a simple idea here for a second. Now, in this expression, again, we have a base, and it is being raised to a power. And what that's telling us to do is that's telling us to take whatever's inside there, our base, and multiply it by itself 3 times. Right? And the reason we get 3 is because of our exponent up here. Now, multiplying across, we're going to get x to the 3rd times x to the 3rd times x to the 3rd, which of course gives us x to the 9th. Right? If I take these 3 and these 3 and these 3, I put them all in the same pile. When we multiply things with the same base, we add exponents. So I'm going to get x to the 9th. And now on the bottom of this expression, we're going to have 2y's, 2y's, and 2 more y's, because we're just multiplying across. We will have y to the 6th. Now, we just did really good math in there. And I don't want to forget about that, but let's just erase the work for a second and see if we can see what happened here. So a minute ago, we started here and we said this was where we got to. Now, I'm hoping you can see the connection here is that to do this, we just took this outside exponent and multiplied it by the exponent of the inside top, the numerator. And then we did the same thing here. We took that 3 and multiplied it by the 2, and that's how we get the 6 and the 9. Great. So again, that rule we were talking about yesterday, I believe we called it PMME, parentheses, mean, multiply, exponents. That holds true. When you see parentheses, we just need to take exponents and multiply them together. Again, we see that here. Now, remember, parentheses again, PMME. This is our general form of the rule here. If you don't see exponents, it is okay to put in a 1 to hold those spots. 1 times m is just going to give us m, so that will be our numerator of the fraction, and our denominator is going to be b raised to the m power. Let's take a look at some other problems here to see what this looks like in action. Again, we do see parentheses. Only difference here is we have a fraction. When we see those parentheses, we know that we need to multiply exponents together. Now, everything on the inside, right, our x has an exponent and our y has an exponent. We don't need to add in any ones or anything like that, so we can just multiply right off the bat. We know that 4 times 2, of course, gives us 8. And 4 times 3 is going to give us 12. So I will have y to the 12th power. So my final answer is x to the 8th over y to the 12th. Great work. Let's take a look at another one. Let's move across here. Here's our next problem. Again, I'm noticing I see parentheses, so I know I'm going to be multiplying exponents. But hopefully you're catching the idea that inside, not everything has an exponent. This 2 does not have an exponent, so we got to give it 1. We got to put a little 1 in there to hold the spot. And same thing with the 3. Now that everything inside has an exponent, we can sit there and multiply our exponents together. So when I multiply 2 times 1, remember our base is not going to change. So I'm still going to have a base of a 2, but now I'm going to have 2 raised to the 2nd power. When I multiply 2 times 3, the base won't change, but the exponent is now going to be a 6. Moving along to the denominator, 2 times 1 is going to be a 2 again, so I'm going to have 3 to the 2nd power. And 2 times 4 is going to give us 8, so I'm going to have n to the 8th power. Now, we should always look at these expressions and say, is there more we can do to simplify? And in fact, this one there is more that we can do. 2 to the 2nd power is just 4. So let's write that as just a 4. And we're going to have n to the 6th up top. And on the bottom, 3 squared is, of course, 9, and n to the 8th. Now, I want you to think back to what we were doing yesterday. Is there more that can be simplified? And our answer is yes. If you notice how we have n's on top and n's on the bottom, n's in the numerator and n's in the denominator, we can sit there and string those out as how we were doing it yesterday. So remember, we could rewrite this as n, 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 6 n's, and then n, 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 and we can cancel out anything we see in the numerator and in the denominator that are the same. And it looks like we're just left with 2 n's on the bottom. So our final answer is that 4 is still, of course, sitting up top. We're going to now have a 9 on the bottom. And then we had 2 n's, so we call it n squared. Now, I'm hoping that you don't always have to sit there and string out all of your variables together. If you do, that's okay. But we should start to look for patterns here as well, right? If I knew that I had 6 n's on top and 8 n's on the bottom, hopefully in our brains we're starting to think about the fact, well, I should have 2 extra n's on the bottom, right? Because 6 and 6 will cancel out and then there's 2 left down there. So let's start thinking about that framework as we go here a little bit more, just kind of deepening our knowledge base. Let's go. It looks like we got 2 problems left to do, and then this video will be over. A nice short one for today. In this problem, it doesn't look like everything inside has an exponent, so let's give that d a 1 there. Now, since we have parentheses, we know that we are going to be multiplying our exponents together. So I'm going to get d to the 4th power over d to the 28th power, because that's what 4 times 7 is, right? Now let's think about this for a second, ladies and gentlemen. If I have 4 d's on the top, we could string out 4 d's, and I have 28 d's on the bottom. Do you see how this is going to get a little repetitive? We know that 4 d's are going to cancel out. And there's going to be no d's left on top. Right? There are 28 down here, total. since there's no number left up top, everything got canceled out. We got to hold that fraction with that 1. And now we look at the bottom and we got to think a little bit. Well, if I had 28 D's originally and 4 of them got canceled out, well, wouldn't that just mean that I have 24 more D's left after these got canceled out? So then on the bottom, I'm really left with D to the 24th power. See, another way of thinking where we don't always need to string it out, right? Math is kind of okay like that, where you can think about things a variety of different ways. Last problem we are going to tackle today is this one. Now, before we multiply exponents out, we got to make sure that everything on the inside has an exponent. We don't want anything being left out. So when I multiply, remember, bases do not change. 6 is a base here, so we are still going to have a 6. What changes in these problems is always going to be the exponent. So I'm going to have 6 to the 2nd power, right? Because 1 times 2 is 2. And then I'm going to have r, 2 times 5 gives us 10. On the bottom, the 3, the base isn't changing. 2 times 1 is 2. And r, the base, won't change. It's just 2 times 2, which is going to give us 4. Now, we can simplify this a little bit more. We know that 6 to the 2nd power is really 36. And we know that 3 to the 2nd power is really 9. Now, let's try to shortcut this a little bit. R to the 10th and R to the 4th power. When you think about that, we know we could string them all out. R. And then do the bottom. R, all the way across. And we could cancel out those pieces that are the same. But instead, what I want you to think of is, what has more, the top or the bottom? And we know quickly the top is going to be the one that has more. And our question to ourselves is, well, I know they're going to cancel each other out, but like, how many more does it have? Because if I knew how many more it had, I would know how many are going to be left over. And we know that r to the 10th, there's 6 more r's here than there were down here. Whoops. So that means we're going to be left with 6 r's at the very end of the day. Now, one last piece we need to add onto this deals with these 2 numbers. If you ever have a whole number in your numerator and in your denominator, that's the top and the bottom of your fraction, what we need to do is we need to sit there and simplify them if possible. Now, we do know that there is a number that goes into 36 and that also goes into 9. And that number is 9. 9 goes into both of these 2 pieces. Each of these pieces can be divided by 9. So simplifying 36 over 9, since I can divide out that factor of 9, we know that this will become 4 r to the 6th. And on the bottom, we're just going to have that 1. And we know that anytime we have something over 1, we can just write it as 4 r to the 6th. And we're done. That's it, ladies and gentlemen. Right, so again, just in kind of recapping our learning here, what the product of a quotient rule tells us to do is it tells us to multiply those exponents, but we have to do it to the top and to the bottom. Remember, if there are no exponents on something, like we saw on a lot of our whole numbers here, the first thing we need to do is add that in. And from there, we just always need to go through and simplify our answers. We saw that in this first one, there was no need to simplify because on the top we had x's and on the bottom we had y's. They're different. But as we moved on through these last 3 problems here, we found there was that need to do a little bit more simplifying. This was only the first step. Multiplying those exponents was only the first step, and we still had to go a little bit deeper. Thank you for watching. If you have any questions, please be sure to contact your teacher. Have a great day, everybody.